So I'm pretty excited about lesson 4.2 today because this is going to introduce our third and last equation for a linear relationship. It's called point-slope form. And so you've already seen slope-intercept, obviously, from last year. Then we introduced standard form in chapter 3 when we were graphing. And now we're going to talk about our third type of equation, which is what we call point-slope. Okay, and we're going to run some of the same things that we did on the previous lesson 4.1, where we're going to write an equation in point-slope form given different types of information, except that now instead of writing it in slope-intercept, we're writing it in this particular form. So let me tell you a little bit about slope form, and here it kind of walks you through how it's created. But point-slope looks like this. So it's y minus y1 is equal to the slope, and then parentheses x minus x1, okay? And we're going to learn how to write this equation from different, types of information, whether you're given exactly the right ingredients, or if you're given a graph, or 2 points, or function notation. And then we are going to really talk about probably the most useful aspect of point slope, which is how to start in point slope, but then work our way into slope intercept, because surprise, surprise, that's probably a more preferred method. So point slope can help us kind of get started, and we can jump in, plug in some numbers, and be in an equation pretty quick. And then once we have it, we can then go from point slope to slope intercept fairly easily, okay? And so before we really start using it, let me give you a little bit of background. So if this looks familiar, then it should, because that's the slope formula. So this is the original slope formula that we've dealt with in previous lessons, right? We know that we can, given 2 points, we can always find the slope by doing y2 minus y1 over x2 minus x1. Well, really point slope is just a slightly modified version of this, where we have taken that denominator and just multiplied both sides by that denominator. So if you could think of us just reorganizing this so that that difference in your x's gets multiplied on both sides, then really this cancels, and you end up with essentially what we have here. We have the difference in y's is equal to the the slope, times the difference in your x's. So really, the point slope is just a reorganized version of the slope formula. It's just having taken that denominator and multiplied it on both sides so that it's up here next to the m instead of it being down in the denominator, okay? So by multiplying each side of the equation by that difference, you end up with this, or if we turn it around, it looks more like our traditional version of point slope, okay? Now, one of the things that's a little bit different is you can see we dropped the y2, x2. We only need 1 point. So this really stays as your variable. The first y and the first x are your variable, the ones that, just like in y equals some x plus b, we have an x and a y. Just like in standard form, we have an x and a y. We'll have an x and a y here, and then all we have to do is enter 1 point, okay? So when you're written like this, it is said to be in point slope, where the slope is the m value. Usual m is always representing slope. And then just any given point can be plugged in here as your y1 and your x1. Those would be the coordinates of any point on the line. So let's talk real quick about advantages and disadvantages. Well, the main advantage to point slope is that unlike slope intercept, you don't have to have the y-intercept, right? You can write the equation, as you'll see in just a moment on these guys, right? You're going to be able to write the equation of this line given any point at all that passes through the line. It does not have to be that y-intercept. So that is its advantage and also kind of its disadvantage, okay? And I'll tell you why. Because if you can pick any point on the line, the reality is that a line has infinitely many points. So, if we were working a problem in class and I maybe wasn't specific about what point to use, maybe some students on the class would pick 1 point along the line, some other ones would pick a different point, some of the other kids would maybe pick this other point. And so when we plug those numbers in, our equations would look different because we're using different points, but they would all be correct. And that's where, it's kind of a good and a bad, because we might not feel really confident. Well, mine doesn't look like my neighbor's. Or it doesn't look like Monsieur Reda's example, right? But that doesn't necessarily mean it's wrong. So it's a double-edged sword, right? It makes it easy to work with because any point on the line works, but it also makes it a little bit, makes us less confident sometimes because, our equation could look like a lot of different equations. It would look different with different points, but it would still be correct. So it's not unique, right? Where slope-intercept is unique. When we are in slope-intercept form, it's like its fingerprint, right? There's only one possibility for every line. So you'll see that in action in just a bit when we start talking about going from point slope to slope-intercept, okay? But right now, let's just practice using it because I want to be really clear about what's probably the hardest aspect of point slope. So let me show you what that is. So on examples 1 through 3, we're going to write an equation in point slope. So now that we have different forms, always pay attention to which one they're asking you to use, okay? So we want to write an equation in point slope that passes through the following point and has the given slope. So these are pretty standard, not pretty standard, but pretty simple because they're giving me exactly the ingredients that I would need, right? So they're starting us off easy here. When they tell me that my line passes through this point, that immediately tells me that I can use this as my x1, y1, okay? And when they tell me that it has a slope of -3, then clearly I can use that as the slope. And then it's just a matter of inserting our numbers in the appropriate place of of point slope. Okay, so if I think about what that looks like, well, x1 is -1, so that x value is going to get dropped right in there. Okay, and I'm just going to put that -1 in there. The y1 is 2, so that's going to be inserted right here. And the slope is -3, so I'm going to insert that right there. Okay, and then I just insert each number. So I'm going to write y minus y1, and I know y1 is, in this particular line, is a coordinate of 2, so I'm going to plug in a 2 there for y1, equals, and then I'm going to put in the slope, which is -3, open parentheses, and then x minus, and then I'm going to insert the -1 where x1 is. Now, if I see minus, which is always the case in point slope, and then I'm plugging in a negative, I know that minus a negative is really going to become +1. Okay? Now, here comes the hardest part about point slope. The hardest part about point slope is we are finished, okay? And I know it's going to be tempting. Look at that and be like, but it looks kind of messy. And there's parentheses. And Ms. Lloreda, you've always said distribute, simplify, clean it up. And the answer to that is absolutely not if it's point slope. So here's the funny part, right? What's the hardest part about point slope? The hardest part about point slope is not doing more work than you need to, okay? Not going further. If you start to distribute and simplify this, then you are going to get it wrong because you're not leaving it in this particular specific form that they asked for in the directions. Okay, so the hardest thing to do is to not do more work than you need to. As soon as you insert your point and your slope, other than clearing double negatives, we do want to clean that up, right? We do want to fix if we have minus a negative. We're not going to leave that. We're going to clean that up. But other than the signs, we are not going to touch anything else. We are going to fight the urge to try to distribute and combine things and make it look nicer. This is point slope. This is our answer. It is correct. Leave it alone. That's the moral of the story, okay? Don't do more work than you need to, okay? All right, let's try this next one where they gave us a 0.35. This is my x1 and y1 coordinates, and of course the slope is 2. So all we have to do is insert that into the template or the formula for point slope. Okay, so I'm going to write y minus, and then the y coordinate is a 5, so I'll insert that, equals, and then I'll insert my 2 where the m goes, because that's my slope, parentheses, x minus, and then my x coordinate was a 3. And that is it, guys. It's that simple. Leave it alone. Don't try to do more math than that, unless it tells you then to change it to some other form. If it wants the answer in point slope, you are finished. This is it. Okay, so go ahead and pause the video and see what you get on number 3 here. Try it on your own, and then you can check your answer. So on this one, on number 3, check to see if this is what you got. All we did was identify the x1, y1 and insert them where they go. And if you do have double negatives, yes, you're going to clear that. So y minus a negative 2, you should be finalized as y plus 2. Okay, x minus a negative 1 should be finalized as an x plus 1. And then for our slope, it was negative 1, so you can just write the negative, or you can write the negative 1 if that's perfectly fine too. And this is what your answer should look like. Okay, and if you got that one right, then you are in good shape, right? And again, the hardest thing is just to fight the urge not to do more math than you need to. Okay, so identify the slope and the point in the line. So now we're going in reverse. They are giving us the equation in point slope, and we want to gather this information or extract this information out of that. So we're literally going in the reverse order. So think about a couple of things, right? Remember, the equation is y minus the value. So what you're going to do is you're going to look at what was subtracted. Essentially, your ordered pair is always going to end up being the opposite of what you see because it was subtraction. So when I see, you know, if I kind of just model this as y minus y1 equals m, and then x minus x1, then when I go to identify my points, well, actually, let's do the slope first. That's easy. So m is always that number in front of the parentheses there, so that's going to be the 1/3. But then when I go to identify my ordered pair, I have x minus, and then 4 is the value of x1. So even though I see x minus 4 here, I've got to understand that that means that my original x coordinate was a positive 4. The formula that's using the subtraction is not belonging to the x coordinate, right? And same thing here. The formula was x minus the y term. So when I see that negative there, that's actually the original sign in the formula, and my y1 is just a 6. So it's basically you're going to end up with the opposite signs here than what you were seeing in the formula itself. So this would be the slope and the point that we can identify from that point slope. Okay, let's try with this one. If it helps, again, write the formula underneath, and that might guide you to be able to extract the right information here. So our slope for this one is -2. And here, that's what I was saying, be careful. So we have y minus y1. So if I see a plus, that indicates to me that there must have been a double negative there, because we were subtracting something and we ended up with a positive. So it must be a -5. So we're going to end up, oh, and I put that in the wrong spot. So that's a -5 for the y. And for the x value, I see x minus 1. Well, that's exactly what the formula shows. So x minus, and then that tells me x sub 1 is just a 1. So this would just be 1 there. So whatever I see here, I end up with the opposite sign. Whatever I see there, I end up with the opposite sign as far as the ordered pair. The slope is the slope, so that I don't have to worry about that. Okay, so go ahead and pause it here. Go ahead and pause it and try number 6. See how it goes. Okay, so check your answer. If you said the slope was -3/8 and the ordered pair was a -2 and a -3, or a -2 comma -3, then you're right. You're right on track. This is exactly it. We have the slope is always right there in front of the parentheses, and then our coordinates are going to be essentially the opposite sign of what we see in the formula. Okay, so if we feel good about writing point slope and reading point slope, then let's talk about writing the equation of a line from graphs. And they still want us to write it in point slope, so we're still going to just put it into point slope and leave it alone after that. Okay, but number 7 and 8 and 9, they're having us work this off of a graph. Okay, so remember, point slope means I need a point and I need the slope. So I still need to find the slope of this line if they didn't give it to me, so I'm going to use the graph, or you could use the slope formula since you have ordered pairs. but I'm going to go ahead and use the graph to find the slope of our line so we can get started. So if I go from this point to that one, I have a rise, it looks like, of 4 units, and then I have a run of 2, right? So the first things first, we had to find the slope, which is the rise over the run, or in other words, the change in y over the change in x. And for us, that was that 4 over 2. Well, 4 over 2 is just 2, right? So our slope is 2. Okay, and then to write things in point slope, other than the slope that we just found, we need a point. This is, like I said, where it can get a little interesting. Any point on our line will work, and we have 2 that are labeled, and that's where, again, it's a good and a bad, it's a double-edged sword, but it doesn't matter which one you pick. Okay, so you could go with that 3, 2, we all do that, or you could go with the 1, -2. They will both work and be correct. Okay, so one option here to write our equation would now be to write this equation in point slope as y minus the y coordinate, which is 2, equals 2 times, and then x minus the x coordinate. And if you boxed that and left that as your point slope equation, correct. Okay, that would be right. But I could also just as easily have picked the other point, and it would still be right. Okay, so the other option here might be to write y minus, and then plugged that y value, if I'm using this other point here, that would be +2 because the double negative cancels, equals the slope, parentheses, x minus the x coordinate. And this would be equally correct, right? So again, this is where it's easy because you can use any point, but it's a little hard because you can use any point. So both of these are perfectly right. Neither of them are incorrect. They both are referring to the same line, but they look different, right? And that was just 2 points. I mean, the reality is I could have come in here and grabbed any other points, and then we'd have even more options. So it's not unique, right? We could write a lot of different equations for the same line, and they would all be right. Okay, so if that happens, I will accept any answer that is correct, as long as it's right. So let's try this next one. For number 8, first we're going to find the slope. Remember, rise over run, change in y over the change in x. If I go from one point to the other here, from left to right, I'd have to go down 3 units here, and then to the right 3 units. So this is a decrease of 3 units, and then a run. So our slope here would be that -3 over 3, which simplifies to -1. So we have a slope of -1, and then you could pick either point. Doesn't matter which one you pick. So maybe I'll just go with that 1, 2, and then I can write my equation in point slope. So y minus the y coordinate equals our slope, parentheses, x minus the x coordinate, and that'd be fine. And if you had used the other point, that would be okay too. Okay, so that is one option, but not the only option. Okay, so go ahead and pause it here. Try this last one. See if you can get it right, and in a minute we'll check it. Okay, so I got a slope of 1/2, up 1 over 2, up 1 over 2, up 1 over 2. So that's a slope of 1/2. And I used the -2, -3 point. So that was my option. You could have used the other one. And my equation ended up being y plus 3 equals 1/2, and then parentheses x plus 2. So this was my version. If you had used the other point, then you would have gotten y plus 1 equals 1/2, and then x minus 2. And that would still be correct. They both would work. Okay. All right, so that's graphing in point slope from a graph. Now let's get a little more realistic, right? We're going to write an equation of a line in slope-intercept. So please pay attention there, right? So we're going to write an equation of a line in slope-intercept form that passes through the given points. And we're going to practice how to write it in slope-intercept from point. Oh, that should say point slope. That's not right. So slope. Sorry for the typo there. Okay, so we're going to write an equation in slope-intercept from the given points using point slope. Okay, so both of these have the word slope in them now, at least. So which means we have to find the slope. No matter what, guys, we're always going to need the slope. That's just the moral of the story, right? So let's go ahead and do that. Let's use the slope formula here, find out what the slope is so we can get started. We'll do y2 minus y1. So the difference in your y's, 7 minus a negative 5, over the difference in your x's, negative 1 minus 2. For this, I get 12 over a negative 3, which gives me a slope of negative 4. So that is my slope right there. Okay. Then we are going to take that and one of the points. It does not matter which one of those two we use, they should both work. So I'll start with, I'll grab the first one, negative 1, comma 7. The idea is that because the ingredients I have are a slope and a point, that it might make sense to get started, at least for now, get started in point slope, because that's what I have, right? Those are the ingredients that I have, so that's the cake I'm gonna bake, right? If I have a point and a slope, then let me go into point slope, and then after that I can move it to something else if I need to. So let's go ahead and write the point slope. Well, that would be y minus 7 equals negative 4, and then x plus 1. Okay, and if we wanted point slope, I'd be finished. I'd be done. But now what we're going to practice is taking something that is in point slope and then changing it to our more preferred version, which is slope-intercept. Okay, slope-intercept over here, yeah, which is that y equals mx plus b. Well, it only really takes 2 movements to do this, guys. Okay, step number 1, distribute. That's step number 1, distribute. Okay, so we're going to distribute the negative 4. That's the first step. So when we do that, we're going to get negative 4x. And negative 4 times 1 is negative 4 again. Okay? Step 2 is move the y value, right? So move the number with the y over here. So in this case, move number that's with the y. So we're isolating the y coordinate basically. And in those 2 quick moves, guys, we are now, drum roll, in slope-intercept, right? So all we had to do was distribute the 4, the slope, right? In this case, negative 4, and then just move the 7 over after that. And I get the y by itself equals, there's our slope, still hanging out with us. And then negative 4 and 7 is a positive 3. And this is the equation of the same line, but it's written in slope-intercept, which I think for obvious reasons we tend to like better. Okay, so that's one of the places that probably point slope is most useful, is to just kind of get us started. But then after that, a lot of the times, not always, but a lot of times we'll then move into slope-intercept form after that. And it just takes 2 quick moves, basically distribute and then move the number over, and that gets you into y equals mx plus b. Okay, all right, let's try this next one. I'm going to kind of make a line here so that they don't run together. So first things first, let's find our slope. So we're going to find the difference in our y values and the difference in our x values. And that gives me 8 over negative 8, which is just a negative 1. So here, my slope is negative 1. Okay, now this one, I can kind of avoid all this work because what's the other ingredient I need for slope-intercept? Well, it's the y-intercept. Guess what? These are both intercepts. This is my y-intercept right here. So if I'm being pretty clever about it, I might catch that, oh, here's my b value. It's 8. And then we can just jump right in to our equation in slope-intercept. Right? So pay attention. Sometimes they actually give us the y-intercept and then we don't have to do a whole lot of work. But let's actually practice this again one more time just to make sure that we feel good about it. So let's write, neither of these are the intercept. We can see that right away. Okay, so we're just going to find the slope of the line. So let's do the difference in our y values. That's negative 1 plus 2. Difference in the x values, negative 4 minus 3. Okay. and that is a 1 over, and then that gives us a -7. Okay, so there's my slope. My slope is a -1/7. And then I pick one of the 2 points. Neither of these are y-intercepts, so we did not get that lucky on this one, which is good practice. So I'll pick that second point this time. And we'll start in point slope. So I'll start off by writing y minus a -1, which is +1. And then putting my slope in here. And then x plus the 4, because that's the opposite of my x-coordinate. Okay, and there's point slope. If we wanted to stop here, because the directions had said just leave it in point slope, we'd be done. But they did ask us for slope-intercept, so we're now going to do these 2 quick movements, and those 2 movements will get us from point slope into slope-intercept. So movement number 1, distribute. Okay, so I'll distribute the fraction. That'll give me a -1/7 x. And then when I do negative times a positive here, it's another negative. And 1/7 times 4 is 4/7. Okay. And then that was movement 1, was just to distribute the fraction, the slope. And then step 2 is just to move the 1 over. So we'll move the 1 over to this side, right? So I'm going to move 1, I'm going to do -1, -1, but I already know that when I line that up with my like term, I'm going to need a common denominator. So when I do -1, I'm actually already going to write that 1 as 7/7, right? Hopefully y'all are keeping up and you know that that's still -1. -7/7 is still 1. So I really haven't changed anything here, but I'm writing it as 7/7, so I'll have a common denominator to work this. Okay, and so now I can do that. Y is by itself. That was the whole point. There's my slope still hanging out in front of x. And when I do this, a negative and a negative, I'm going to add that and make it a -11/7. And that is my slope-intercept form of that equation. So 2 quick movements there. Once I have it in point slope, all I have to do is distribute and move the constant to the right, and you're in slope-intercept. Okay. And then very much like the last lesson, when you're given information in function notation, don't let that kind of scare you away. It is still the exact same information, right? Just like here we were given 2 points, 2 points, 2 points. This is still just giving us 2 points, just using function notation to do so. So when I see that f of -3 is -1, all that is telling me is that when the input was a -3, the output was a -1, and that is an ordered pair together. When I see f of -2 is 4, all that is telling me is that when x was -2, the output was a +4, and that is an ordered pair together. And the rest of this is like deja vu, guys. We just find the slope. We always need the slope, no matter what. So 4 minus a -1 is 4 plus 1. -2 minus a -3 is -2 plus 3. And for me, that's a 5/1, or just a slope of 5. Okay. Then, because what I have is the slope and some random points, I'm going to go into point slope, at least at first. Okay, so I'll start off by y. Let's see, which point do we want to use? I guess we can use this one. Okay, we'll use the -2, 4. So we'll do y minus 4 equals, and then our slope of 5. And then x minus a negative becomes x plus 2. And there I am in point slope. If we wanted to stop there, that'd be fine. But this is talking about functions. By nature, we want to leave things in function, input, output. So we're definitely looking at slope-intercept, because this is the one that's set up as an input and then solved for an output. So we definitely want to go into slope-intercept here because it's a function relationship. Okay. But again, we know that that requires just 2 quick movements. Movement number 1, distribute the 5. All right. So we're going to come in here and distribute the 5. That gives me 5x plus 10. Okay, movement number 2 is move the number that is with y over to the right. And that cancels, and I get y equals 5x plus 14, right? And then I can really rewrite this in function notation. This whole thing was in function notation. I want to be consistent. So really, f of x equals 5x plus 14. That's how I really want to establish my answer. That's the function that represents that. Okay, so I'm going to go ahead and stop it here. Try 14 and 15 on your own. Use this as a guide to help you, and then in a moment we'll check it. Okay, so check number 14. If you got f of x equals 2x plus 5, then you are in great shape for this lesson. The slope should have come out to 2. I used -2, 1. You could have used the other point. That's kind of one of the neat things, is we talked a lot about how point slope isn't necessarily unique and it could look like different things and still be right. But the cool thing is that no matter what point slope version, if it's right, when you change to slope intercept, we will all have the same answer. There's only one option or one true slope intercept for each line. So even if you had picked the other point, the 1, 7, you know, this piece of it, the point slope might look different, but then when you solve for slope intercept, you would get exactly what I got if you did it correctly. So f of x equals 2x plus 5 is the equation of this line, no matter which point you use to plug in, as long as it was on the line and it was correct. Okay, so hopefully you got that one as 2x plus 5. And here's number 15, f of x equals -1x, or just negative x, plus 8. So the slope was -1. You can use either point to jump into point slope, but then when you solve y and you simplify, you end up with f of x equals -x, or -1x, and then plus 8 is the y-intercept. Okay, so that is how you can use point slope to get started, but then still write your equation in slope-intercept with pretty much 2 quick, easy steps. Okay, all right, let's finish up with some couple of word problems. 16 through 17, tell whether the data table can be modeled by a linear equation. Explain if possible. Explain, and if possible, write a linear equation that represents y as a function of x. So, you know, we're looking for constant. This is a little bit more review in, you know, a type of review question. But the first thing we want to do is to decide if something is linear. It's all about whether there's a constant rate of change or a constant increase or decrease. So, and that's really the change in y over the change in x. So let's try that. If I compare from -3 to -1, that's an increase of 2. From -1 to 0, that's an increase of 1. From 0 to 1, that's an increase of 1. And this is an increase of 2. Okay? So 1 plus 2 is 3, and so forth. Now let's compare that to the change in how the y's changed. So if I go from -110 to -60, that is an increase of 50. That went up by 50 there. Okay. If I compare from -60 to -35, that is an increase of 25. If I go from -35 to -10, that also increased 25. And from -10 to +40, that increased 50. So when I compare, remember, this is all about, is the change in y over the change in x ratio the same? Well, this change in x, sorry, this change in y over this change in x is 50 over 2. Well, that simplifies to 25, right? This change in y over change in x is 25 over 1. That also simplifies to 25. This 25 over 1 obviously also matches. That's 25. And then this one is 50 over 2, but that does still simplify to 25. So all of these, even though we kind of, you know, they weren't the same every time, the ratio was the same every time. The change in y over the change in x, 50 divided by 2, 25 divided by 1, 25 divided by 1, 50 divided by 2. It was always 25, okay? So that tells us that, yes, this is, since the y to x ratio is constant for all the points, this is linear. So yes, it is, okay? And now let's talk about writing the linear equation for it. Well, for the linear equation, we need a slope and a y-intercept. We already know the slope. The slope is this constant change that we got every time. So that was m. Let's write that here. And then, of course, the other thing that we need is the y-intercept. Did they give us that here on our table? Yes, they did. So remember, the y-intercept is where x is 0. So it is right there, 0, negative 35. That gives me the b value. So my equation here, or my function, would be f of x equals mx plus b. For this, oh, I don't know where I got that. It should be an x. Okay. 25x minus 35. That would be the equation that models that situation. Okay. Let's try the same example, or the same situation here. From -3 to -1, that's an increase of 2. Then this is an increase of 1. Very similar. Increase of 1, increase of 2. And that's okay, because what really matters is how did the y change, and is the ratio still constant. So from -98 to 18, that is an increase of 116. Okay. From 18 to 8, that is a decrease of 10. From 8 to 62, that is an increase of 54. And I probably could quit already, but I'm going to do this last one. This, I think, is an increase of 80. That one's easier. Okay, but when we compare the change in y over the change in x here, this first change in y over change in x was 116 over 2, which simplifies to, what would that be, 58. Okay, this one is -10 over 1. Guess what? -10 over 1 is not 58. Those are not the same, right? And then I've got 54 over 1, which is also not equal to the other two. So I've got plenty of evidence already, and I could go on to the last one and get a 40 there, that the answer is no, right? The rate of change, the change in y over the change in x ratio is not the same, or it's not constant. It is not constant for all the points. Okay, over here it was constant for all the points. So that's what we're always looking for. All right, let's talk about Craig. Craig is driving at a constant speed of 60 miles per hour. After driving 3 hours, his odometer reads 265 miles. We want to write a linear function that represents the miles driven after X hours. Okay, so let's think about what we know. When they tell us that he is driving at a constant speed of 60 miles an hour, they basically have just told us our rate. That is our rate, our speed, right? That's our slope in our line. They've also told us that after driving 3 hours, the odometer has clocked 265 miles. So 3 hours is equivalent to 265 miles. That gives us an ordered pair, or a point. Okay, so we want to write a linear function that represents that relationship. Well, I have the slope and I have a point, so I'm going to capitalize on what we just learned and start off in point slope and then write my function after that. So because these are the ingredients I have, this is where I will begin. I'm going to start off by doing y minus the 265, and then a slope of 60, and then x minus the 3, and then just move things around like we said, distribute that 60, and we'll rewrite it in function form. So I'll distribute the 60, that gives me that. And then in the next step, we will just move the 265 over. So move this guy, and that's y equals 60x. And then when I combine those, I get an 85. So there's our function. Okay, the f of x function that relates this would be that right there. Okay, apparently the odometer started with 85 miles on it, and we're going 60 miles an hour after that. So what is the odometer going to read after 7 hours? Well, remember, x was the hours, so by giving me that there's 7 hours, they've given me an x value. I already have a function to work off of. I can solve anything I want with that, right? I can just solve for f of 7 and just plug that in to the function we just generated and see what we get. So after 7 hours, 60 times 7 is 420, plus the 85 would mean that the odometer after 7 hours would be reading 505 miles. So after 7 hours, the odometer would read 505 miles, okay? Try number 19, and in just a moment, we'll check it together. Try it on your own and see if you can set it up and solve. Okay, so check number 19. The Student Council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different amounts. So was it linear? Yes. The rate of change was always the same. The ratio of the change in y over the change in x was always 12 over 2, 12 over 2, or in other words, 6. So that was a constant rate of change. So it's linear. To write a function, I used that same rate of change as the slope, and any given point would work. But when you write the function itself, it ends up being 6x plus 10. So f of x equals 6x plus 10. And then to interpret those, well, since this is the increase for every foam hand, the price is going up $6. That must be the cost of each of the foam hands. That's the rate of increase for the price. And then the y-intercept being 10, that's probably some initial cost not associated with that per foam hand price. It could be a shipping charge. It could be setting up fee for setting up the school colors or logo, things like that. So there's like an initial $10 charge in addition to that. So see if you did that one, successfully. And if so, you're in good shape. If not, make sure you come talk to me in class. Have a great day.